So I'm still looking at this power supply issue where this one here, this section is not generating plus or minus 15 volts. Now it seems like it's the plus 15 volt rail which is causing the issue, because the minus 15 comes from the plus 15 supply. So that's like the basis of what it's doing. Now I've measured the inputs to the op amp, which is what these two wires here are. The error correction from the reference supply is there, which I fixed previously in an earlier bit. But the other supply here, which the op amp must be using as a comparison, isn't there. Now that runs through, it's got the resistor networks here, and it's got this resistor here, which is R13. That's supposed to get a feedback from the plus 15 volt rail in order to balance it out, so I can work out what its actual output is. So it's a closed loop section of it. Now I actually overlooked this before, because I did a measurement and I got a resistance, but what I didn't actually check was that the resistance was correct. So if I go in there now, try and get the probe on there, it'd be good. Why is it not measuring anything at all now? Hold on. Maybe it's completely gone now. But, it's supposed to be not that. That's 56k. Well, it's supposed to be 11.576. So, very wrong. So I think that resistor in there has failed. Just like the resistor on the other end of that circuit, because that resistor feeds that one which failed on the other board, passes through that one. So, is it? Oh no, sorry, it doesn't. No, it doesn't. It's separate. But because that op amp blue has probably stressed that resistor, probably shorted it out, and it's blowing that resistor as well. You know, visually, I can't see anything wrong with it, but it must be blown as well. So I'm going to have to look into that some more. I mean, I can't see anything wrong with that resistor. Yeah, I might take it out and have a closer look. Actually, I just reread the diagram. It's not a 11.576k, it's 11.576 ohm. So that's definitely way off then. Right, so because of the precision of the resistance I need to do in order to repair this one which is blown, the 11.5 something ohms. Hold on, what is it supposed to be again? Lost it. Yeah, 11.576 ohms is what it's supposed to be. Now, I've had to make something, right? Just a collection. I mean, it's obviously not going to be as good as the original part, but as long as I get the resistance value pretty close, it should be alright. Or at least good enough. So, it's just, I've got my A5A2 out just to do this. So I've got the probes on one leg together using 4-wire measurement. So let's just set the offset, turn it off. That looks pretty good. And let's see what we get. Now, I think I can't really get any better than that. You know, that's really close to what the original value is. So also thinking I should probably revisit that other one I prepared, which is out by half an ohm, and just play around with that and try and get that closer, because I'm not actually happy it's not correct. So I'm probably going to redo that one as well. But yeah, that's what I need to get onto. So I'm going to put this part in and replace that one which is burnt out, and see if that improves the situation at all. So, right, so I've got the little microscope out. I'm going to look at this resistor I pulled out. This is the R13. Now, just there you can actually see within the wires, the wire comes up and it stops. I can't see any other damage to it. It all appears to be okay. But when you come over to the actual mountings here, I'll try and get into my place. It's a bit, I've got a bit of paper so it's a bit springy. There's the mountings. So there is actually just there. Here you go. Try and get it in my place and focused. There's the wire, just there. See where it's attached on there, and there's the wire disappearing off. So the wire is actually broken off right there. So it's probably physical damage rather than electrical damage in this case. You can see where it's supposed to be there. At least it appears to be there. So, unfortunately, that's the end of that part. Yeah, I don't think that's going to be repairable somehow. Now this part here is the one which I already replaced on the other board, and the amplifier board. The amplifier board? Reference board, sorry. Now if you look at these, I thought it was a bit strange the way it had actually gone. If you look at it, it looks like there's scratches in it like that. Almost as though someone's hit that with a grinder. So there's horizontal scratches across each winding, see that? We've been cut into. And there were some stray wires around, there you go, just there. They've been ripped out. So I actually think that someone's been working on the board with a Dremel, probably trying to cut something off, and they've touched that with the Dremel and destroyed that part. Just looks a bit odd to me, having those scratches horizontally and all that. Isn't what you expect to see. Alright, so this is the part that I did substitute in that resistor, just here, which I bodged up. You can see it's out by about half a K. It was supposed to be 86.75 ohms. Half a K, half an ohm. Alright, so it's actually, you know, a fair bit out. I thought, well, it probably won't matter that much, but yeah, it may do. So what I'm going to do, what I've done here is I've made these ones up, which is an abomination. It looks absolutely awful. Alright, this is just temporary. I've got plans to make this much better. And we're getting that. So it's a lot closer. It does actually drift up to be basically bang on, because I've been touching it and I've just been soldering it a short time ago as well, so it's probably not stabilised fully. Let's just stick it on there, let it sit. Just 30 it as well actually when I'm doing this. That's pretty much there, isn't it? Right. So let's just try and get that to display. So it's supposed to be 86.75 ohms. So as you can see, it is very, very close. I think once it's fully cooled down for me not touching it, it'll be basically bang on. No, it's milliohms, 10 milliohms. You know, is that good enough? Probably. You know, it's an awful looking thing. It looks appalling. I've actually ordered some resistance wire. So my plan is to actually try and wind a new resistor and replace it with a nice part instead of this abomination. Alright, so this isn't going to stay there. It's easy enough to get into it and get the thing in and out. It's not a problem to do that. So I've ordered some wire. I'm gonna try and wire wrap around some kind of former and get the correct resistance. But as you can see, this is very, very close. So I'm happy with that as it is, for testing at least, to confirm it's okay. Right, so I've got a suspicion, based on the theory of how this power supply is working with that floating supply. In fact, it's not generating the correct voltage now, it's now generating 12.8 volts instead of the 23 it was generating before when it was open circuit, which would say to me that it's actually sensing the voltage too high. Now in the circuit diagrams for this unit, it said that this resistor here, which failed, is an 11.576 ohm, right? It says R. But I'm looking at these other parts thinking none of the other parts which are in ohms say R. They only say K if they're in K. And the guide on the circuit diagrams also says it's in ohms unless otherwise stated. So I'm thinking, this doesn't seem right. Now I've set up the resistor here. Now I can just get to the very edge. I can see the wire where it's broken off right there. I can just see the end of the winding. Now if I'm really gentle and really careful, I can just touch it. And I can just read the value of this resistor. So I'll stick a probe on that end, try and get onto that wire. You should be able to see on the Vici. Come on. Do you see that? 11.5K. See that? 11.56K. So the accuracy of this thing is not great, so it's going to be as per the manual, but it's K, not ohms. and I've painstakingly put together a 11.576 ohm resistor, and it's supposed to be K, so that would explain why it's wrong. Now, because I can just get to the wire here, what I'm actually thinking is I might be able to repair it. Now, you can't really see it very well on there, unfortunately. I'll try and get this angles a bit different so you can see it. Let's try this, eh? Let's adjust things a little bit. Now, there we go. There's the wire there. Just see it poking out, or hooking around. Hopefully you can see it on the camera. You might be able to. Hold on. There you go. So you can just see the little wire there hooking out. Alright, that's the end of the winding, which was going to the binding post on the other side, which is broken off here where it's been hit. You can actually see it's chipped. Alright, so I think it's actually pulled out of there. It's supposed to be wrapped around, and it's been pulled out. So if I can solder onto the end of that wire, I can repair this resistor. How's this for a challenge? Something so small I can't even see it. I mean, there's the wire. There's the tip of these tweezers, which are extremely fine. Alright, there you go. Look at that. There's really small tweezers. Alright, so I may or may not be able to fix this. If I can solder onto that wire, I might be able to fix it. So I'm going to give that a go. You know, the other wire, which is broken off, I can just see here. It's just there. I can't quite wrap around. It's been deformed and damaged, so I can't really do much with that. But I might be able to just maybe pull a bit more out and go to that post there. Might be possible, and that's the same piece as that. It's just one piece that goes right up. Equally, I don't want to snap it off, because if I snap it off, I've got, you know, I'm stuffed basically. So I mean, there it is there. This is extremely fine wire. Right, look how small that is. So I can't even see the thing. I can only see it in the magnifier. But yeah, basically I've got to get it from here over to here. It's a bit short. So if I get the other piece of wire which is broken at the other end, try and desolder that off and try and have a piece of wire, I can try and tack that on and reattach it. It's worth a shot. I'd rather use the original part if I can. It's not going to be easy, really not going to be easy, but it might be possible. It might actually work. So I'm going to give it a go. Alright, so I've just put a little bit of dab of flux pen on it, and I'm going to see if I can get any solder to stick to it. That's the first thing, otherwise I might be wasting my time. So let's have a go. Well, I'm not sure anything's happening. Well, the wire's still moving. It's not embedded in the stuff anyway. Now, what I'm actually wondering is if I heat this up a little bit, I might be able to pull that wire out and get it onto here. Actually, I might be able to move it over rather than trying to attach onto it. But now I've actually lost the wire. I thought, oh, it's gone. I can't see it now. It's out of focus. Yeah, it's still there. It's just out of focus. Alright, so this is going to be extremely tricky. If I can heat that up, I'm better get the wire out. Pull some of that wire out of there. And then reattach it. I'm just trying to be really careful not to break it, because at the moment I've got something to grab hold of. So let's just warm this up with the soldering iron and see if I can pull some out. Soften it right up. It might be enough to get the wire out then. So small. It's probably one of the smallest things we've ever worked on. Well, I pulled a little bit out. It's not great. There's a lot more than that. So if it breaks, I've got a problem. Okay. Come on, where's it gone? Gone off camera. This is so small. Can't see, I've lost it now. It's just there. It's not looking like a great prospect for working. So I'm really worried about breaking it off. Oh, I've just lost it. Uh-oh, I think it broke off. Oh no, it's still there. Right now I can't even see it at all. Incredibly small. It's there. Let's see if I can get a little bit further away to make it a bit easier for myself. Right. So change the angle to try and make it a bit easier to see. But yeah, it's just it's not looking very hopeful. I mean, basically what I was trying to do is scrape the resin away with the soldering iron, and I was going to try and solder onto it originally, as I said, but that's not going to work. So let's just see about trying to get this out of the resin. If I can soften the resin enough, then that's a possibility. I mean, it is softening, as you can see. So come on, get hold of it. Oh, yes, gotcha. Gotcha. The wire is out till there isn't enough for me to solder on. There's the wire there. I've got enough out. Right. Nervous. Obviously this is going to change resistance very, very slightly. Right. Resistance isn't going to be perfect anymore, but it's not going to change it by much. Let's just have a look. Clean this up a bit so I can try and get onto it with the soldering iron. Man, what a mission this has been, eh? God. I know you can't see this right now, I'm just trying to get myself set up. I'll pause a second, come back. Now I can probably zoom out slightly actually. There you go. Right. So what I've got now is a little fiberglass brush, just try and clean up this connection here, which I can then hopefully attach the wire to. It's not scraping very well actually. It's something a bit more aggressive. So it's got that resin there. I can see the wire, so that's good. So make sure I don't cut the wire accidentally, that'd be really bad. So I'm really, really nervous about this. I can either repair it with this or completely destroy it. So, anyway, I'm hoping for a repair. Get under here so you can see what I'm doing. Maybe you can. There's the wire, and there's the bracket thing there I'm trying to get onto. It's there. I'm trying to get this nice and polished up so I can get a good solder connection. Trying to get some nice clean copper. Looks like I've got that. Right. Stick some flux on there. Another wire as well, so I can get to it. Fingers crossed this works. Okay, yeah, we've got solder on there. Great. Now, where's the wire? Such a fine, fine wire. I think it's in there. I think it's in. I've lost it. There's the wire just sitting on there. Needs a bit more solder. A bit of fresh stuff. Crap off there. Oh, pop back out. Come on. Stay in there. See, it's just sitting there. Not being easy to get in. Oh, that might be it. It was, but I moved. Go without breaking it. Right, let's measure it. Does it work? Does it work? can see that, can you? Let's make this up a bit. Right, fingers crossed. Ha 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 ha! It works. It works. Now, so it's slightly off value, but it's going as close as anything I can make, probably, to be honest. So, and certainly it's the right part. So I'm going to refit this onto the board, which I've got sitting just here. I'm going to take this out of there and correct that, and go from there. Right, let's get this part out. Now what I've done is I've put some of my liquid electrical tape over all that to try and protect it so it doesn't get damaged again. So it's going to take a little while to go off, so I'm going to put it right in straight away. So I can get this other part out at least. We just try to desoldering it, but it's not quite there. Okay, so that's sorted out. So I mean, this did work, but well, not right. It wasn't the right value. So you know, stuff happens. There we go. Right, so it's ready for that other part to go back in again. Once the protective coating I've put on has dried, because I definitely don't want it getting damaged again. That'd be a bit of a nightmare, really. So I was lucky to fix it this time. I was actually surprised I was able to fix it. It's just flattening out again. So yeah, all good. I shall do that shortly, and I'll be back once I've got it done. Right, so whilst I'm waiting for this sealant to dry, I've just got my Fluke. Well, I've had this on for about half an hour now, so it's fairly well stabilised. Let's just get a good connection there. Give it a chance to settle, set the offset. And let's see what we get on actual reading. So I don't trust Avicii as far as the readings go, it's not the best thing. So 11.5448 K, so it's out by a little bit, wasn't it? What was it supposed to be? 6.5 or something, 5.65. So 20 milliohms, 20 ohms, sorry. Yeah, 20 ohms out. Does it matter? I don't know. We'll find out, but hopefully it's close enough. It's only a small difference, you know, percentage wise it's not a huge amount, but it's 0.1%, so yeah, it's outside of its tolerance really. So yeah, let's see how we go. Right, so if you look at the Fluke 45 here, you'll see 6.955 volts, and that's measuring this connection here, which is wired down to the board, which is the voltage fed in from the reference adjustment, well, reference to the power supply. So that is working correctly now. That's the first time I've seen that correct. And let's see what this wire does. Yeah, that's close-ish, slightly different, but it's okay. So those are looking correct. If I click onto it, probably be a bit better. So that is bang on exactly what it's meant to be. So now I just want to test the power supply voltages. I've still got errors on here, still not working, but the it's a step closer. Let's have a look. It should be about 15, I think. Minus 15.4, that's within spec. Yeah, almost 15, that's within spec. So those are good. There's also supposed to be a 20 volt around here somewhere. I've forgotten where it is. There it is, there's 20 volt there. So that's all working too. So that power supply is definitely working now. That's the end of the power supply problems. Now I'm carrying on with the other stuff. Let's just see if I've got any output now. I've got that corrected. AC. It's still showing overload. Interesting, when I first connect up, I see a spike in voltage, but or if I change ranges, you see it jump up a little bit and then go away again. When I go to 1000 volt range, it actually trips it back into standby. So it is actually doing something when I'm changing ranges. But so there is some life in it. So something's happening. It's just not fully working yet. So I think once I get to the bottom of that overload indicator issue, what's causing that, I think I'll probably, next thing I'll be doing is checking the oscillators, make sure they're working, because it's got a 10 MHz oscillator in here, one of these boards. Check all that, check those frequencies are working, because without those the whole thing just won't work. So that's probably the next step, and go from there. If the oscillator's okay, then I'll be looking at I'll just following through then for the boards and just trying to see, what if I'm getting a voltage on the amplifier input, which is this board here. It's a power amplifier board, so I need to check that one for an input. This is the one I was testing earlier in the video, or maybe last video, depends on how I set it up, and I didn't find any faults on that one. 1000 bar solder joints, but that's about it. And so yeah, we'll go through it, but it's at least now the power supply section is definitely working correctly. The reference adjustment reference feedback to the power supply is definitely working correctly. So that is all good so far.